6. Observation is important for gathering knowledge about the universe. Some thinkers in the history of philosophy valued armchair philosophy and claimed that productive results cannot be acquired by observational methods. It is, of course, possible to set up philosophical arguments or to develop mathematical theorems by armchair philosophy. Knowledge can be obtained by thought experiments used in philosophical arguments or by theorems set up by deductive methods in mathematics without using observations. Part of the knowledge gained this way in philosophy and mathematics is also useful for natural and social sciences. For example, philosophy can help clarify the methodology of science, and mathematics is invaluable to both natural and social sciences. But while philosophy and mathematics are valuable, without observations, we don't gain any knowledge of the world. Without observation and experimental methods, it would have been impossible to discover the periodic table in chemistry, the inner structure of the sun, or the organelles of a cell. Experiment, perhaps the most important and fundamental method of modern science, is a process of observations systematically performed under precisely specified conditions. The belief that experiment is a successful method is based on two fundamental presuppositions. The first, the main focus of this chapter, is that observation is a reliable source of information to understand the universe. One who does not regard observation as a source of information cannot regard experiment, systematic observations, as an important method. The second is our fourth presupposition. The laws of nature are universal. The idea that the observations in laboratories are essential to understand the processes in nature is based on the presupposition that the laws of nature are equally valid in the laboratories. Similarly, repeatability, the primary criterion of the experimental method, assumes the universality of laws. The laws do not change over time. As a result, a mindset with these two presuppositions would identify experiment as important and useful. Today, virtually every scientist accepts observations of the phenomena of the universe or observations conducted in the laboratory as fundamental sources of information. But we learn from the history of science that observation did not play such a fundamental role in the past. In ancient Greece, many prominent thinkers did not appreciate the importance of observation, except in the case of practical knowledge. Plato, for example, claimed that knowledge is unchanging, eternal, and timeless, ultimately of the so-called forms, and this kind of knowledge can be acquired only through pure thought. Observation of the changing and temporal is not only not helpful in this process, it is misleading. Although Aristotle, by attaching the forms to matter, developed a philosophy which affirms observations more than Plato did, his epistemology science still seeks knowledge which is metaphysically necessary, like mathematical propositions. Contingent observations cannot attain to necessity. According to Aristotle, the aim of knowledge is to comprehend the eternal forms attached to matter. Once one comprehends the essence of an object with rational thought, one can infer everything related to that object by deduction. Inference, not observation, is the way of knowledge. Even though observation is useful in comprehending the essence of the objects, it is not mandatory, since essence can also be comprehended by pure thought. So observation does not play a central role in Aristotle's thought. Other civilizations observed the phenomena in the universe to be safe from the floods or to make use of them in farming or in agriculture. While they gave importance to gathering observations of nature for their practical benefits, they did not require observation for knowledge of the universe. Supposing that all knowledge can be acquired by contemplation is an enemy of observation-based inquiry. So is supposing that everything about the phenomena of the universe can be learned by consulting the views of certain people who supposedly have solved all the problems of the universe. A famous anecdote nicely illustrates this influential attitude. A person asked how many teeth a horse had. He was told, "Let's look at Aristotle's book." Ibn al-Haytham rejects this reliance on tradition. The seeker after the truth is not one who studies the writings of the ancients and, following his natural disposition, puts his trust in them, but rather the one who suspects his faith in them and questions what he gathers from them, the one who submits to argument and demonstration, and not to the sayings of a human being whose nature is fraught with all kinds of imperfection and deficiency. The rejection of Aristotle's authority was an important step toward the emergence of the scientific revolution of the 17th century. The Quran, for its part, deeply affirms observation. The Quran does not tell us to learn everything related to the universe from the Quran. It encourages believers to make observations and to draw conclusions about the universe. The Quran does not see observations and inferences drawn from them, which is science, as a threat to its authority. Rather, it holds that the results acquired through observation and inference as confirming its claims. Consider two verses encouraging observation of the universe. Travel on the earth and see how the creation started. There are so many proofs in the heavens and in the earth, but they pass by and ignore. The first verse invites us to examine the phenomena on the earth and to gather knowledge of the creation. The second criticizes those who ignore the evidence in the world. One who reads these and countless similar verses would understand that one cannot comprehend all the details regarding the processes in the universe and on the earth only by reading the Quran. One can and should gain knowledge by observation and examination. In short, the Quran constructs a worldview which values observations of the phenomena in the universe. The tremendous success of observation-based science has been well established. Every contemporary scientist now assumes the importance of observation. While they make this assumption, most don't have adequate grounds for it. The Quran, as noted, encourages observation independent of its practical outcomes, encouraging us to make observations which will help us to better comprehend the creation. To that end, these verses require a qualified comprehension. The Arabic words used in the Quran to direct us to the universe mean contemplating, reflecting, and penetrating. In short, the presupposition observation is important for gathering knowledge about the universe, which has an important role in the scientific processes, is supported by many Quranic verses, which encourage observing the universe.